Alright, let's take a look at questions 6 and 7 now. And so 6 wants us to determine the average rate of change on an interval, in this case from 3 to 6. And this should say from x equals 3 to x equals 6. But that's the interval that we're determining the average rate of change for. And so to find the average rate of change, we want to evaluate the function at the right endpoint of the interval, which of course is 6, because 6 is larger than 3. And then we subtract the value of the function at the left endpoint of the interval, which in this case is 3, because 3 is smaller than 6. It's at the left end, and 6 is at the right end. And so the formula then is f of 6 minus f of 3, and then in the denominator we find the difference of those two endpoints. The 6 is the largest, so it's the right end. The 3 is the smallest, and so it's the left end. Excuse me. And so we plug in 6 here, and we substitute 6 in rather for x. And so in the numerator we have 6 cubed, and 6 in the denominator, and then 6 here. We have 6 squared here, and then here we have 6 over 2, and then plus 3. Now, excuse me, this is, I did this on purpose because this kind of simplifies, the way this is laid out kind of simplifies the way we calculate this, the way we could calculate this without a calculator. 6 cubed over 6 cancels out one of the 6's, so you have 6 squared up here. Well, this is 6 squared then here, but we're subtracting 6 squared here. So those terms cancel out additively, and what we have left here is 6 halves plus 3. Well, 6 over 2 is 3, so we have 3 plus 3. So this is 6 here on this left side. The value of the function at 6 is just 6. Excuse me. Now the value of the function at 3 requires a little more calculation, I guess. 3 cubed, of course, is 27. One of the factors of 6 rather, is 3, and so then this becomes 3 squared when one of these 3's cancels out, and we have then 9 over 2. 9 over 2. And then this is 3 squared, and we're subtracting 3 squared. 3 squared is 9. So we have 9 over 2, and 9, and 3 over 2. Well, if we give all of these a common denominator, we have 9 halves, and of course 9 is 18 halves. We subtract 18 halves from 9 halves, and that gives us negative 9 halves. And then 3 is 6 halves, and so 6 plus 3 is 9. And so 9 halves and negative 9 halves is 0. So this just simplifies to 0. So 6 minus 0 is 6, and the denominator 6 minus 3 is 3, so 6 over 3 is 2. So that's a very wordy way of saying that this evaluation is really, if you break it down, it's really much simpler than it might at first appear when you see that you have fractions and cubes and stuff like that. Now in part B we are asked what the instantaneous rate of change is at x equals 5. Well, to determine the instantaneous rate of change, we take the derivative of this function. And once again, I chose this function because the power rule is pretty simple to apply for this one. You take the 3 and bring it around front, and of course that'll be a 3 in the numerator and a 6 in the denominator, and 3 and one of those 3's, or the 3 there, cancels, and so that leaves this as x squared and 2 in the denominator. And there you see it right there, x squared over 2. And then the 2 comes around front here, and this becomes negative 2x. And x over 2 is the same thing as 1/2 x. So our coefficient to our linear term there is 1/2. And then, of course, the constant differentiates away because it doesn't contribute anything to the rate of change, the instantaneous rate of change of the function. So now this is our derivative, and when we when we substitute in 5 into that derivative, which is what we should do here, instantaneous rate of change at x equals 5 means that once you calculate the derivative, you substitute 5 in for x. 5 squared is 25, and so we have 25 over 2. Negative 2 times 5 is negative 10, and of course that's negative 20 over 2. And then when you subtract 20 from 25, then you have 5 over 2, and you have 1 over 2 here. That makes it 6 over 2, and 6 over 2 is 3. So once again, just like with this evaluation, this evaluation is actually simpler than it might at first appear when you see that you have fractions. I did that on purpose, and I think that the question on the exam has a similar kind of layout. Now, in question 7, we're supposed to use the derivative to determine the slope of a line tangent to the graph of this function at a certain point. Well, instantaneous rate of change and slope of a tangent line are the same thing, and so we need then the derivative of this function, and so we just use the power rule, bring the 2 around front here. We have negative 2x, and because this is a linear term, that is, the x is raised to the first power, it just differentiates away, and our derivative is negative 2x plus 4. And by the way, when I say that, when it just differentiates away, if that is conceptually, if that's conceptually a little unnerving or not something that is or easily have latched on to, just remember the rule and apply it, and then perhaps later you can make more sense of it. Anyway, that's our derivative, negative 2x plus 4, and we want to find out what the line tangent to that graph at that point is. So we put that x value in, put 3 into the derivative, and that's negative 2 times 3, which is 6, plus 4 is, negative 6 rather, plus 4 is negative 2. That's the slope at this point. 3 and whatever this y value is, whatever this function value is. Well, now we need that function value, so we plug it into the function. And so we substitute 3 for our x in here. And so that's 3 squared. The negative kind of sits out here and waits for us to square this number. And so we do. 3 squared is 9. The negative stays here with that term. And then 4 times 3 is 12. Negative 9 plus 12 is 3. And so the value of the function, or the y value when x is 3, is 3. And so you can see that here on the graph. X is 3, y is 3. And this parabola is the graph of negative x squared plus 4x. Now we need the equation of the line. And so in order to calculate the equation of the line, we just need one point, which we've got, 3, 3, and the slope, which we also got, negative 2. And so y is 3, so we substitute that into the slope-intercept form of this equation. Y equals 3, m is negative 2, and x is 3. And so that gives us 3 is equal to negative 6. You add 6 to both sides. That gives you 3 plus 6 is 9, and that's our y-intercept. So we've got the slope we've got the y-intercept. So that is the equation of the line tangent to the graph at this point. And the only reason I included the graph here was just to demonstrate that, just to show you that this is in fact true. Here's the slope of the line right here. We can see that it's down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and there's that point that the line is tangent to. And of course there's the intercept, there's the y-intercept of 9. Alright, question 8 is really, it's fairly simple, even though we do need to remember our we do need to remember how to express a radical with a rational exponent, in other words with an exponent that's a fraction, and we do need to remember our rules of negative exponents, which we'll go over here in a second. And so your question on the exam will be very similar to this. We have a function here, f of z, and it's 4 times the square root of z minus 1 over 2 times z to the positive 4. Well, in order to apply the power rule, and that's all we need here for this question, in order to apply the power rule, we want to change this square root from square root of z to z to the 1/2. Z to the 1/2. So we write square root of z as z to the 1/2. And the 4 is still there, didn't go anywhere. And then we write the z to the positive 4 in the denominator as z to the negative 4 out of the denominator. Now I could have put it in the numerator, but I thought that it was easier to see what was happening if I left it out here and left the fraction to the left of it as its coefficient. Well, so now that's the function rewritten in a way that makes the power rule more convenient to use, and or easier to understand. And so we take that 1/2 and bring it around front, and in the exponent we subtract 1 from it. Here we take the negative 4 and we bring it around front. So we take that negative 4 and bring it around front, and we subtract 1 in the exponent. Well, we're multiplying 4 times 1/2, and that gives us 2. And 1/2 minus 1 is negative 1/2. And then here for this term, a negative 4 is a positive. 4 times 1/2 again is 2. And negative 4 minus 1 is negative 5. Then we change this, we rewrite this with z to the negative 1/2 being z to the positive 1/2 in the denominator. And of course z to the positive 1/2 is square root of z, and so we write this as 2 over square root of z. And z to the negative 5 is the same thing as z to the positive 5 in the denominator, and so we write this z to the negative 5, 2 times z to the negative 5 as 2 over z to the positive 5. So that's all there is to that. That's all there is to that question.